I wonder who of us has not actually looked up at the stars and wondered if we're alone, and if there's life elsewhere in the universe, and in particular if there's intelligent life like ours. Of course, the first thing we have to do is to define what we mean by life, and the definition I came across from a chemist working at NASA, Gerald Joyce. He defined life as a self-sustaining chemical system capable of Darwinian evolution, a marvelous definition in my opinion. It avoids all kinds of metaphysical issues. But of course, if we're going to look at life and consider whether there's life somewhere in the universe, then we have to recognize that there's clearly a hierarchy, with single-celled organisms at the bottom of the hierarchy, and then multi-celled organisms, perhaps jellyfish. And then as we move upwards, we get to things like mammals, dolphins, for instance. And at the point of the dolphin, we have the issue of consciousness. I think we'd all agree dolphins are conscious, but sadly we are not able to communicate with them. But then the next stage up, I think in terms of ancient Indian civilizations. Now, the universe could be full of such civilizations and we'd never know anything about them, because the only civilizations we're going to be able to communicate with are technologically advanced ones capable of sending and receiving radio signals. So that, of course, is a fundamental limit on our ability to answer the question about life. Now, what do we know about life on Earth? Well, one thing we've discovered in the last 15 years or so is that life, simple single-cell life that is extraordinarily widespread and extraordinarily tenacious. If we look at lakes that are filled with arsenic, Lake Mono in America, we find organisms there, happily living there. If we go to the Antarctic, and we look at the ice, we find organisms living at minus 20 degrees centigrade, and we find organisms that have been buried in ice for 100,000 years at temperatures of minus 40 degrees, and they're still viable, still alive. If we look in the hot springs, we see they're colored by beautiful colors just by the presence of organisms. And if we go to mid-Atlantic ridges, we see smokers where the temperature ranges between 90 and 113 centigrade, and there are organisms living there. Places that we would normally consider, temperatures we'd normally consider those for sterilizing things. I guess the all-time record probably has to go to a salt-tolerant bacterium found inside salt crystals that have been mined where they have been in isolation for 250 million years. So that must be the all-time record for life. So life on Earth is widespread and tenacious. And when we look around our universe, when we look at our universe, we find it's perfectly suited to our existence. And what do I mean by that? Well, the fundamental laws of nature seem to be finely tuned to create a universe that is just right for life. Now, people have wondered for a long time why that might be. Is there some as yet undiscovered super theory that links all the constants of nature together? Or is it because there are many universes, a favorite idea of string theorists, that the multiverse theory? Or was indeed the universe created by some ultimate being, some god? Well, we don't know the answer to that, but we do know our universe is well suited to us. And when we look around our universe, we see, lots of galaxies. We live in a galaxy. We live in a galaxy of 100,000 million stars. When we use our most powerful telescopes to look towards the very edge of the observable universe, we can estimate that the observable universe contains 100,000 million stars. And just to bring us back into the context, because we're always accused of blinding the public with enormous numbers, there are about 100,000 neurons in the human brain. The difference being, of course, in the human brain, they're all multiply interconnected, creating numbers far beyond those that we see in astronomy. When we look more closely at galaxies, we see they are full of dark clouds of dust and gas. And these are the clouds out of which stars are born. And indeed, they're called molecular clouds because they are full of molecules. We know of about 150 molecules in the clouds and comets in outer space. And many of these molecules are the basic building blocks of life. So we have all the material to build life out there. And again, in the last 10 years or so, we've been discovering planets around other stars. And indeed, it seems possible that there may be as many planets or more planets in the universe and in our galaxy than there are stars. So you might well come to the conclusion that life must be widespread. Perhaps simple life appears everywhere. And maybe there must be intelligent life. Because, as we've seen, the universe is perfectly designed for life. It's full of the building blocks of life. There are many stars. There are even more planets. And the life we do know about on Earth is tenacious. So you might think that we have come a little, hardly any distance in the last 2,400 years in our thinking since Metrodorus stated, "It goes against nature in a large field to grow only one shaft of wheat, and in the infinite universe only one living world." But just because something seems reasonable does not make it true. And the problem we face is that we only have one example of, let us say, intelligent life, and that is the life on our own planet. And we're up against a sort of principle, and that principle is one that's been a driving principle of astronomy since 1543, when Copernicus relegated the Earth from the center of the universe to merely orbiting the sun. And the progress of astronomy since then has been one of continual relegation, as we discover that the sun is a very ordinary star rotating round the edge of a very ordinary galaxy, part of a very small cluster of galaxies on the edge of an even bigger cluster of galaxies. And it's almost become a sort of Copernican principle of physics that we do not live in either a special time or a special place. And that is very much behind the thinking that life, if life is here, it must be widespread. But I just want to have a closer look at the Earth and the origin of life on Earth, and just maybe query that supposition. So, what do we need? We need a stable star, and we've got one. It's about halfway through its life. And nothing very special about that. 16% of stars in the sky are the sort of stable star around which, like our sun, around which we orbit. Next, we need a planet that's the right distance from its star that water is liquid. At least we think water's pretty important for life. Now, maybe every solar system has one of those, but the planet has to have just the right mass. Too massive and maybe it'll be entirely covered in water, or it'll have too much hydrogen and helium in its atmosphere. Not massive enough, and by now it will have cooled down, the core will have cooled, the magnetic field will have gone, and the atmosphere will be stripped away. And there's one further special thing about our Earth, and that is that it has a moon, a large moon, a moon the size of Jupiter's moons. And what we need, what is the point of the moon, you may well ask? Well, the moon has a stabilizing effect on the inclination of the Earth's axis of rotation, the thing that gives us our seasons. Without the moon, the axis of rotation would swing wildly by plus or minus 15 degrees, and so we would have enormous seasonal differences between summer and winter. That might not stop life developing, but it would certainly make advanced life rather difficult. If we look further out in our solar system, we see the enormous planet Jupiter. And back in 1994, we watched a comet collide with Jupiter. And Jupiter regulates comets that come into the inner solar system and potentially collide with the Earth. Perhaps we need a few collisions to drive the process, the punctuated equilibrium of evolution, but not too many, otherwise life would never get going. And lastly, we live in the safe zone of the galaxy, not too near the center, where we will have too many encounters with giant molecular clouds, and not too far away. So from the center, where there won't be enough metals to make the planets. So there are a lot of things that seem to make our Earth rather special. And so maybe that narrows down the possibilities of having advanced technologies like we have developed on Earth. And now I want to look quickly at the development of life on Earth. And what you have to ask yourself as we go through this is whether what happened on Earth will happen everywhere, or whether it was perhaps unique or a very rare event. Now, the story of our Earth starts just under 4,500 million years ago. The Earth was formed, and then we experienced what's called the late heavy bombardment, when the surface of the Earth was heavily disrupted. And it is only after that, at an age of about 3,800 million years, that we see the oldest rocks that we find on Earth today. And almost immediately we see traces, the first evidence for life. So here is the first great mystery. Life appeared on Earth almost as soon as it could. And why was that? Was it created here, or did it come from somewhere else? And this is a good incentive to look around the rest of our solar system for primitive life. And believe it or not, the Earth is not the only place where we find water. There's evidence for water on Mars, there's evidence for seas beneath the ice of Europa, a satellite of Jupiter, and even as far out as Saturn we see the moon Enceladus that has jets of steam coming out of its surface, while Titan has lakes of liquid gas that might be another environment for life. And comets seem to be black with the organic molecules. And furthermore, we have the ability to pass life around the solar system as a meteorite is knocked off one planet and arrives on the other. And we've certainly collected meteorites on Earth that have come from Mars. So far, we've found no evidence for life elsewhere in the solar system, but I'm quite optimistic that we might, and it'll be very exciting to see whether it's like life on Earth or some completely different form of life. And of course, if it was, that would strongly suggest that wherever life can form, it will form. Now, the second great mystery of life on Earth is why it remained single-celled for as long as 3,000 million years. And all the precursors of all the animals and plants that we see around us today have appeared within the last 600 million years. There are various reasons why that might have been, the build-up of oxygen in the Earth's atmosphere perhaps, but we can't be sure. So for most of the history of the Earth, it had nothing but single-celled organisms. Only in the last 600 million years have all the other plants and animals developed. And if we look at that 600 million years, we see that there were 5 major catastrophes when life was almost completely eliminated. Now, these major catastrophes are probably very important because they would have been the driving processes of evolution, because during a catastrophe, populations are reduced to very small numbers, and it is from small numbers that we think that a wide variety of organisms emerges by the rapid process of evolution to fill up the available ecological niches. Now, the last major catastrophe we know about was 65 million years ago, and that was at the time when we believe the dinosaurs became extinct. And it was also round about the time in India when we had the great outpouring of the Deccan traps, enormous volcanic eruptions. And there was a huge disaster then, the dinosaurs were wiped out, but it was from that catastrophe that the mammals emerged, and we, of course, are a mammal. So we owe our direct origin to that catastrophe. Incidentally, I said we'd had 5 catastrophes. Now we're into a 6th catastrophe. The rate at which species are disappearing today is equivalent to the rate at which they disappeared in those previous catastrophes, though perhaps not as instantaneously as a comet impact. But of course, we know who's responsible for the catastrophe today. It is, of course, ourselves. So, we had 600 million years for the development of all the multicelled organisms, and it's about 7 million years since we shared a last common ancestor with chimps. It's a mere less than 1 million years since we discovered how to use fire to cook. And something strange seems to have happened in those last 800,000 years or so, perhaps something people refer to as the origin of mind, something that fundamentally distinguishes us from the rest of the animal world. Our ability to associate ideas, not just a matter of tool use and intelligence. We see tool use and intelligence in crows. Crows can make a little hook to fish out meat from a place that they can't reach with their beaks, so they not only can use tools, but they can show intelligence. Whereas something fundamentally different seems to have happened in the development of the human mind, our ability to associate ideas, to think abstract thoughts, to create all kinds of art and technology. Now, whether that always happens or whether it was something that very rarely happens, we simply have no idea. And when we look at the last 100,000 years of our development, we see the earliest 100,000 years ago, the earliest examples of human decoration with ochre. We see the earliest examples of jewelry, engraved ochre and shell beads, maybe a mere 70,000 years ago. And then the Ice Age ended 18,000 years ago, and then we have the first cities, and in no time at all, we visited the moon. Is that an inevitable trajectory? I don't know. I rather suspect it isn't. So we come to the question, is there intelligent life elsewhere? And of course, we've spent quite a long time listening with radio, and a lot of you will have heard of the SETI experiment, been doing that for nearly 30 years now, and so far found nothing. Since then, of course, we've discovered a more powerful way of communicating using lasers, and if we were to use the world's most powerful lasers with the world's most powerful telescopes, we could send a signal 1,000 light years into space. Not far on the scale of the galaxy, but there would be many hundreds of thousands of stars within range. We're not actually doing that because it's not really practical at the moment, but we have set up telescopes to listen for such signals. And sadly to say, although some of them have been running for nearly 10 years, we found absolutely nothing. So it does seem to be silent out there. Well, this takes us back to 1961 when the Drake equation was invented by Frank Drake, set up an equation to try and estimate the number of civilizations we might expect in our galaxy. And he put in all kinds of factors, and we don't really have time to go into those today, but it's basically trying to work out, how many stars, what fraction of habitable planets, and so on and so forth. And there is a crucial number, and that is the length of a civilization. How long does a civilization last? With the most plausible numbers we think of today, if a civilization was to last about 1 million years, then there'd be 200,000 of them at any one moment in our galaxy. It would be positively teeming with them. But if a civilization only lasted 100 years, there'd only be 20. And that estimate is for the most optimistic estimates of how many habitable. It basically assumes that every planet that could develops a civilization that communicates. If we just put down the numbers to 1 in 10, say that 1 in 10 planets has a habitable star. 1 in 10 solar systems has a habitable star. And in 1 in 10 cases, life arises, and in 1 in 10 cases, intelligent life arises, and in 1 in 10 of those cases, communicating life arises. Then, and that's still quite a high number, then we find that if a civilization lasts 50,000 years, there'd only be about one of them around at any one time. On our Earth, civilizations, the oldest civilization is about 5,000 years old, and we've only been technologically advanced for the last 100 years or so. So I suspect the reason it is silent out there is perhaps because technologically advanced civilizations are not stable, do not last long enough, and perhaps that is the great lesson to ourselves. And in my opinion, perhaps the greatest threat to our civilization is indeed ourselves. And perhaps that is the most important idea that comes out of pondering why it is that we're alone, because we are indeed a civilization that doesn't have too great a hope of lasting long enough to find any other civilization around. So I just want to finish with a couple of few final thoughts. Are we indeed the most complex beings in the universe? And if there are other civilizations, will ours last long enough to make contact? But on the other hand, if we are the only thinking, self-aware beings in the universe, is it important that we survive? Will the universe be a worse place with nobody in it to observe it? And finally, I'd like to quote John Haldane from his papers, Possible Worlds and Other Papers, published in 1927, and he says, "I have no doubt that in reality the future will be vastly more surprising than anything I can imagine. Now my own suspicion is that the universe is not only queerer than we suppose, but queerer than we can suppose." Thank you very much.